So my name is Tim Roughgarden. I'm head of research. Very excited to be here. You'll be hearing from introductions to almost the entire research. Actually, the entire research team is here. We were all just very excited to participate. You'll get introductions from all of them shortly. So I thought I'd just spend a few minutes talking about the research team in general and sort of how we interact with our portcos. Because life on the research team, it's really kind of two different worlds that are actually much more integrated and synergistic than you might expect. On the one hand, everyone on the research team is not just kind of a consumer and is not just knowledgeable about cutting-edge research. Everyone on the research team is expected to contribute to cutting-edge research themselves. So you will see like major papers in crypto with the names of A16Z crypto researchers regularly. You will see that multiple times a year. That's part of the reason why we hire the people that we do. The other half of the job is really just to collaborate directly with our portfolio companies. A lot of people actually think the job is about due diligence, like outside, and it is a little bit of that, but honestly, it's much more the fun stuff where you take the portfolio companies we've already invested in, and right, it's not just, we don't just sort of cut the check, we also want to help those portfolio companies to succeed, and that's kind of the Andreessen Horowitz philosophy, and the research team is very much kind of in that same spirit. So we are regularly, there's dozens and dozens of companies in the portfolio that we meet with regularly. Sometimes it's very lightweight. Sometimes it's kind of just like office hours. They want to sort of hear about what are the relevant research papers to the problems they're working on, or they just want kind of another set of eyes on a design. Sometimes we're really in there sort of working together collaboratively, and sometimes the research team really actually sort of deeply influences what the eventual product is. And they sound maybe like totally different activities, but they're actually really related. It's not just that our sort of deep knowledge of the research enables us to be that much better a collaboration partner in solving those problems. But I gotta tell you, just like selfishly, like in an immature field like this, where you can't just kind of read last year's conference papers and figure out what the important research problems are, the competitive advantage we get as researchers by being at A16Z Crypto and talking to people like you all the time is unbelievable. I genuinely feel like I get about an 18-month advance notice on what's going to be the important papers to write compared to if I was just sitting in the ivory tower. So it's super exciting for us to talk to all of you. One, we just think a lot of you are building amazing stuff. Secondly, it's sort of our little way of seeing around the corners about where the science and technology is going. So that's going to be my intro. Let me head it off to Eddie.
These are the members of the research team that are going to be here today. Daniel Renaud, who you may know as Karma, who's in the back there, he has a background in formal methods, but is also a smart contract engineer. So he's very deep in EVM, and that the combination of skills is why Karma works very deeply on Halmos with Daejun, who's also here, which is our symbolic execution and testing tool. So if you're writing EVM code, you're concerned about the EVM code being correct, and you really want it to be correct in a way that's maybe more interesting or deeper than standard tests or even a little bit of fuzzing could do, you should talk with Daniel and Daejun. They'll be in one of the breakouts that we recently added to the schedule based on security. Daejun was also at runtime verification in the past and has a lot of experience with security auditing and has relationships with people in security auditing. So if you have questions about that, Daejun would be a great person to pick. Michael Ju is one of the co-authors of Jolt, one of the co-implementers of Jolt, along with Sam Ragsdale from the engineering team. And he'll be joining the ZK breakout group later. And so if you have questions about Jolt, which is our general purpose ZK VM, you should definitely ask Michael. We would really love to support you if you want to use Jolt, like extra special. That's like a special moment. So please, if you want to do Jolt, I would love to talk to you. Sagar does a lot of things within the firm, besides being very deep in, like, for example, Farcaster's background, backend implementation, hub implementation. Sagar was also at Solana a while back and is very, very familiar with the Solana virtual machine and so on, but also generally security practices, signature schemes in different contexts. He's sort of a generalist in security as well. But I think he's going to be in the incentives group because he thinks a lot about such things. I'll say more later. Noah, many of you should know since he's staying in London during the program. Noah is also a bit of an applied cryptographer recently, so also a great generalist. But if you have questions about L2s, if you have questions about optimism, if you have questions about light clients, if you have questions about any of those things, I think Noah is the right person to talk to. So that's a quick cut of the engineering team.
The research team sort of falls pretty naturally into two halves. One, which is the side focused on incentives, market design, mechanism design, kind of business strategy. So we're going to start with an introduction to that half of the research team. And then the other half is in various flavors of cryptography, ranging from ZK to MPC to all kinds of other things. So that'll be the second half. Similar format for both. So I want you to get to know the team members a little bit, and then also just hear a bit about the kinds of work they do, both on the sort of pure research side and in the Portco collaboration side. And then there'll be at least some time for just general Q&A in each of the two sessions. So let's start by having Pranav and Scott. I'd like we'll start with Scott, then move on to Pranav. So just to kick things off, just a little bit about sort of who you are, your background, the kinds of things you like to work on, and then I'd also like to hear specifically something you're really excited about on the research side, right? I mean, I think this is an opportunity for the group to really hear from people that are literally at sort of the cutting edge of research. So it could be your own research or just something else that you're sort of super excited about that's happening kind of right now on the research side. Maybe also just kind of at least one anecdote about the kinds of collaborations you've had with our portfolio companies thus far. So Scott, we'll start with you.
Great to meet many of you and see a few of you for the nth time. Thanks so much for beaming me in. So I'm Scott Kominers. I'm a research partner at A16Z Crypto. I also teach at Harvard Business School and in the Harvard Economics Department, and I'm a market designer by training. So I study the design of markets and market clearing mechanisms, and more broadly, how to think about sort of the incentives in a system and how to use a mixture of like economic reasoning and computer science and sometimes a little bit of applied math to shift the incentives or to change behavior in a way that improves outcomes, right? So it's about, it's like economics is a perspective on the world. It asks, how does the world work? How do people respond to incentives? And then what does that do to outcomes? Market design asks, how should the world work? Sort of how can we use economics to change and improve outcomes? And as such, I've been in different capacities involved in crypto for a number of years at this point. And of late have been thinking particularly about a lot of consumer crypto applications. But I work with teams both sort of on the research side and in terms of the portfolio on everything from sort of like the fine-grained details of tokenomics to like much higher level strategic questions, like how do you maintain competitive advantage and capture value. And in fact, maybe I'll talk about a story that links both and sort of is feedback back and forth. So one of the first things I noticed when I joined the research team was that I was having tons and tons of conversations with teams about versions of the question, how do we do our initial token allocation, or how do we think about the right mechanism for selling individual units or something of the sort? I was talking to a lot of companies that in one fashion or another manage NFT projects or have developer ecosystems where they're trying to deploy tokens as a way of incentivizing developers. Sound like anybody in here, maybe? Tim's smiling, good. I actually can't tell whether people are laughing. The room is not mic'd, so if people are like guffawing, it's got to make it to the front mics.
I would say smiles, but not guffaws. So.
Fair enough. It's early in the morning here. Sorry, my comedic timing's way off. And there are some patterns. There are some things that you've probably seen happen a lot, right? Teams will do something to try and identify and label their, sort of their expected top contributors, or they might have, various forms of challenges or contests. You've seen versions of, retro PGF too, right? Sort of situations where you sort of try and look and later assess like what created a lot of value and how do we reward that. And so we found we were giving a consistent, on the one hand, we were giving a reasonably consistent set of recommendations to teams. We were sort of spending a lot of time telling them, okay, so tokens, people's incentive, first order economics, right? People's incentives to invest in building value around the token depends on the share of tokens that they hold and like sort of the way and as a function of the value they internalize. And you want to bring in people who drive, who have significant externalities, significant benefits that they drive to the entire group, or sort of that they drive to the ecosystem. But there actually was no formal framework for thinking about how to actually do this correctly. But it turns out the tools of mechanism design, in fact, like a particular branch of mechanism design that I and a number of collaborators have been working on for years, made it possible to make this really formal. So normally when a lot of the classics of mechanism design theory assume that sort of everyone in a market is the same from the perspective of the designer, that you don't care who receives, given units or whatever, other than whatever they're willing to pay you for them or something of the sort. But that's not true when you're building an ecosystem. When you're building an ecosystem, there are externalities. If you're launching an NFT project, you maybe care about having marquee members or people who are going to invest a lot in like developing their characters, if what you are is like a character brand. If you're launching a developer ecosystem, you care about bringing in the developers who are going to work the hardest and produce products that are of the most value to the broader ecosystem. With users, you maybe worry about congestion, or God forbid, adverse selection, where you have people who just acquire the token because they're purely speculating and have no desire to build. Again, sort of not sure whether that happens, but and so with a team of collaborators, we've built a mechanism design framework, and we're now calibrating it to sort of give direct predictions as a function of sort of how you understand the externalities of your user base. And it makes very precise predictions, right? It says things like how you think about substitutability and complementarity, like cross-subsidizing different groups of users. And, or for example, a common intuition that we have is that we might want to induce some sort of, or require some sort of token vesting to sort of reward people as a function of their ongoing contribution. But there's a precise reason for this that the math spits out, which is that people's behavior in in an ecosystem, people's desire to select in, isn't a function of how much they think they can contribute. It's a function of how optimistic they are about the future value of the ecosystem. And those people are sometimes the best builders, but they're not always the best builders. And so by requiring, if you just distribute a token immediately, and most of the value is to be developed downstream, right? It doesn't exist yet. Maybe some people who are very optimistic about the ecosystem will acquire it, but everyone else will just sell it. Whereas if you induce vesting and sort of, especially if you can tie that vesting to project milestones, then you actually have a more virtuous selection pattern, right? It isn't just that you give people a reason to stick around, but you actually endogenously, sort of as a function, like the incentives select for the users who are actually building the value, because those are the people who, capitalize the most in this vesting model, or those are the people who like get the most value by sort of in the long run, because they know that they can invest to grow the ecosystem. And so on the one hand, it delivers a lot of economic intuition. On the other hand, it delivers literally like there are things that look like formulas for how you sort of think about calibrating these allocations. And then since writing a paper on that and thinking about it as a researcher, we now take that to teams, and I spend a lot of time helping teams think about this in context, and more broadly, like sort of what these ideas about like how the cross externalities between different types of users affect questions about how you should scale your platform, like who you should try and bring in when, and so forth. And critically, again, right, it's like as a researcher, we both provide intuition. We're both explaining things like, look, what you're seeing is a selection effect, right? So you move up or down depending on which direction you're going, the demand curve. You're actually drawing in different types of users, and you have to think really hard about like how you identify the different categories of users who are most valuable, and try and select for the ones that are actually going to build along with you. And then, we spent a lot of time looking at protocols. Like literally yesterday, I was on the phone for an hour with a team where they were running me through the details of their actual like primary sale protocol and sort of then what they think the feedback loop is going to be. And we sort of deconstruct them and try and help them build them better. Anyhow, it's that. Sorry, it was probably slightly longer than originally expected, but hopefully gave a sense.
No, Scott, that was great. So, Pranav.
Yeah, so hi, my name's Pranav. And so, I'm a research analyst in the team, and have been doing have a similar background to Scott in various kind of mechanism design research problems, and have been doing that for about 5 or 6 years now. And then for the past kind of 2 or 3 years, have really been focused on blockchain problems. And I think kind of while Scott focuses, well, he does a lot of things, kind of focuses a lot on the application layer, I kind of look at the infrastructure layer a lot more closely. And so a lot of my research is kind of understanding what's been coined the transaction supply chain. And basically, in different L1s and different ecosystems, basically, how does a transaction go from users, and then there's like searchers and builders, and kind of this whole pipeline before transaction fully might land on chain. It's part of some block the proposer kind of puts out there. And so I kind of study a lot of the mechanism design questions that go along with that. And so if people might have heard about things like PBS or order flow auctions or anything along those lines, a lot of kind of what I'm working on is trying to understand how do those things work today? How can we kind of formalize the guarantees those things give you? Kind of asking questions around, what properties would you want the supply chain to give you? How do you kind of measure, are like users getting good execution, or users having good UX experiences? Are these kind of systems decentralized? Kind of what are the different economic forces in play when we kind of add all these different parties? And so I kind of try to answer general questions around the whole supply chain in general. I think one thing that's been really interesting for me as of recently is trying to understand kind of these newer kind of like high performance L1s. So kind of in our portfolio, we have Aptos and Sui, kind of Solana, and really understand kind of like how does the supply chain differ in these environments compared to something like Ethereum. And so in Ethereum, things have been have evolved a lot, and there's lots of kind of research attention from lots of people in the space trying to understand these different mechanisms, understand kind of the properties you want. And I'd say that's kind of way less developed in some of these different L1s. And so maybe one concrete example is one thing I study a lot are these fee mechanisms. So basically, on Ethereum, this is things like gas prices, just like how are those prices set, how much users have to pay. And then on Ethereum, there's been a lot of work kind of, starting from what Tim did a few years ago. And I think at this point, we have a pretty good grasp, basically, of there's some ways we can say the current fee mechanism is somewhat optimal, and we kind of know the exact trade-offs anybody can make. But I'd say the question gets a lot murkier when you move to different L1s. And one key reason is because Ethereum has this basically a single dimensional environment. Everything happens sequentially. Whereas a lot of these kind of newer L1s are trying to use these parallel execution environments. And that means kind of the resource constraints that transactions have changes a lot. It's a lot harder to measure kind of like how much compute does it take to execute a transaction, when not only you have to worry about kind of executing the transaction itself, but what other transactions does executing one transaction block for various like parallelism concerns. And so that in turn leads to it's unclear how to charge fees in transactions in these kind of newer ones where everything's kind of parallel. And so a lot of at least one project I'm working on right now is working with the Aptos team pretty closely and some people on the Solana side of trying to figure out are there new fee mechanisms we can use to really kind of in some sense, kind of unleash the full potential of like the block space that these kind of higher performance L1s offer. And that's partly algorithmic challenges of just the fact that you have to solve in kind of technical terms this like multi-dimensional knapsack problem versus single-dimensional knapsack problem is actually way, way, way more complex, and we don't understand it quite as well. And there's also just various incentive concerns of just kind of having all these different resources means the kind of information you might want to extract from users submitting transactions is a lot more complex, right? And kind of something like Ethereum, maybe you're happy just having them report like a total gas cost, and that's actually a pretty good proxy for how long a transaction might take. But when you're in these parallel environments and there's kind of all these different parameters that might affect, how performant a transaction can be, there's this trade-off of how much you want to allow users to express, right? Do you really kind of go the Solana route and make, users express these like full access lists and tons of details that can be really helpful on the pricing side, but also kind of open you up to different types of grouping attacks of people manipulating how they submit these parameters to kind of get favorable pricing. On the other side, something like an Aptos makes very few requirements of users to submit information about their transactions. And so that puts more strain on the Aptos side when they're like kind of charging fees, they have less information to work with, but it's better UX potentially for developers. And so a lot of what I work on is trying to really understand those trade-offs at a fine-grained level and kind of figure out, can we say something about what's optimal given kind of the use case you want?
Let me ask you a follow-up question, Pranav. So, because you talked about the separation of the infrastructure and the application layers, and you sort of pitched yourself as sort of focusing on the infrastructure layer, right? But like you have this one phrase I really like actually, which is you can't black box the blockchain, right? Which really is kind of about how you're actually sort of working on the application layer in a way, or you're informing the application layer design also. Could you say a little bit about what you mean by that phrase?
Yeah, so one of the main benefits of blockchains, as Tim says a lot, is that this computer in the sky that kind of anybody can use and share, but it doesn't mean you do have to share it. And so what else is happening from other applications can actually really impact what your application is doing. So I think it's it'd be really nice if you're at a point where you could basically assume this computer was perfect and you could submit things to it and it would execute it and you would get back some great response. Unfortunately, we're not quite there yet today with how the kind of infra stack is set up. And so I think as somebody building applications, it's really important to kind of understand how this transaction supply chain will affect you. So if you're building a DeFi protocol, it's not a good idea to assume, I'll have my transaction and then that'll just land on chain the exact way I want it with nobody else seeing it. You have to be quite careful of knowing, okay, I'm going to submit my transaction. It's going to go to some type of mempool. There's going to be some set of searchers, kind of interested financial parties, kind of looking at that transaction. They're going to maybe insert things before or after. They're maybe going to try to manipulate that somehow by manipulating some other type of market. And then there's going to be some kind of long process of some builder or something's going to have to package my transaction and get it in the block and then submit some bid, kind of blah, blah, blah. There's kind of a lot of contingent reasoning, basically. And so the main point is you should definitely be kind of mindful that you are in some sense in the dark forest, and that you really kind of should be, I think, adversarially thinking, especially kind of on the DeFi side and kind of any kind of side of any applications that really do interact with state in complex ways. There's lots of parties who might try to mess with you, and it's important to kind of design your protocol with that in mind. It can also be helpful sometimes, right? By being in this kind of scenario, everybody is kind of looking at what you're doing. You can use MEV style things to your advantage. Of sometimes having auctions, with having arbitrageurs can be something that takes something off your plate. If you can assume that there is some type of your market that'll be corrected by just the market deciding it versus you kind of explicitly having to control for something, it can also help you out. And so I think being mindful of that whole process is quite important. And even if you're not doing something DeFi related, even if you're doing a more kind of traditional app layer thing, it's still important to think about how these kind of transaction fees and blocks getting full can affect you. You should be mindful if kind of my application is assuming every single block there will be some transaction included, and that's actually very crucial to some UX flow that's happening off chain. It might not be the case you get a transaction limit every single block. There might be some random thing happening on chain, and the infra things get weird in MEV world, and there's some blocks that can look very weird. And so if there's a span of 1, 2, or 3 blocks where your transaction doesn't land, you should be mindful of what's happening off chain is kind of prepared for that. And so I think just having a good, at least a high level understanding of this whole kind of transaction supply chain and exactly how blocks get built from a high level is important, just to have kind of the right contingencies in place and kind of be mindful when you're designing different applications.
Scott, let me ask one more question to you, and then I'll open it up to the group for Q&A. So Scott, you kind of have multiple different universes you're in at the same time, but just purely on the academic side, right? In addition to kind of the market design expertise that you bring, right? You also teach at Harvard Business School, right? And you have for many years.
Yep.
You've been a professor there. And early in your career, you would be teaching sort of basically, Web 2 business strategy. And then as things have evolved, right, what became more and more interesting to teach was Web 3 business strategy, which you have basically had to invent in order to even teach it. And so I'd love to hear just a little bit about your thoughts on that side. So what changes on the business strategy and value capture sides going from Web 2 to Web 3? And I know there's a million things you could say here, but maybe if you could keep it to maybe 5 minutes, ideally, that would be great.
Yeah, exactly. I'll pick 2 or something.
Okay.
Yeah. So just to illustrate, and as Tim says, I've been teaching various forms of marketplace and platform design, both in our MBA and our graduate program for a number of years now. This year, we just launched a new course called Building Web3 Business, where we were literally teaching Web3 business strategy. And so we had to do, both all the thinking. Again, Tim says we're, talking to portcos brings us to the forefront. Luckily, I'd been doing a lot of this thinking with teams for a year and a half leading into it. Major changes. So first of all, the sources of competitive advantage have really changed substantially, right? If you think about the Web 2 business model, you're probably all used to thinking of Web 2 as, there are these platforms who lock everybody in and they lock in data and they build these walled gardens. And Web 3 in a large part is about breaking out of that, because we think it's value creating to enable data to be individually owned and to transition sort of seamlessly across platforms. But from a business model perspective, that's actually a huge shift, right? Because these Web 2 platforms are all have business models that are built around their ability to hold everything in this enclosure, and to use like sort of their network effects as a source of gravity, and usually in some way to become extractive over time. Right. Sort of you have users, and then eventually like they're so locked in that you can show them lots more ads or charge them more money to use your services or something of the sort. And Web3 breaks a lot of that, right? Sort of there's this classic framework. We have an article that's soon to be circulated on what's called the 5 forces. There's this classic framework of like the different sources of competition, competition from existing competitors, buyer and seller bargaining power, and then sort of potential new entrants and potential substitute products. All these different sources of competition in an industry get stronger once you have interoperability that comes from an open platform like a blockchain. Right now, if a competitor wants to recruit sort of your top customers, they can see who they are and they can directly incentivize them to switch, like in a vampire attack. Users can vote with their feet, which raises their bargaining power. And all of this makes value capture in the traditional forms more difficult. Right? You don't have these locked in, sort of network effect walled gardens, and at the same time, sort of competitive forces get stronger. However, first of all, critically, like Web3 doesn't eliminate network effects, it just changes where they lodge, right? So instead of the network effects accruing to the platform, they accrue to the protocol or to the digital assets, right? The protocols that are used most frequently, the digital assets that are that people want to use in as many places as possible, have a tremendous network effect built around them. This sort of embeddedness can become a tremendous source of competitive advantage, right? If your protocol, you think it's a little bit like the security that comes in a blockchain, right? If your protocol is the base layer of another protocol that is the base layer of a third protocol that is the base layer of a fourth, it's really difficult for anyone to disintermediate you, even if they would potentially like to fork, because you run the risk of like everything else breaking above them, and then their business falls apart. And so we've seen this in open source software pre-blockchain, and it's much stronger here, where you can additionally add an incentive loop. Embeddedness is a core source of competitive advantage, and that can eventually lead to value capture. And we're starting to see bits of that too, with protocols starting to turn on small fees for interactions. And then another, which is, to my knowledge, basically special to Web3, I don't think there's sort of a real instance of this that we've seen at scale before, is you can also drive incentives through community cohesion. You can also drive competitive advantage through community cohesion by either incentivizing or just driving, by having people want to engage in your ecosystem rather than a competitor's or something of the sort. And shared ownership is a really powerful way to kick off that loop, to get someone invested in your ecosystem and want to be a part of it. So anyhow, I've spent a lot of time thinking about bits and pieces of these different classic platform competitive frameworks, and then how we transition, how we compete in Web3, and then again, critically, what that means for value capture. And again, it's the type of thing that both I study as a scholar, and you have lots of conversations with teams who are asking versions of this, right? How do we stop ourselves from getting forked or disintermediated? How do we sort of drive community engagement in a way that promotes sort of long-term platform growth and sustainability in a world where users could leave? And how do we capture value? How do we know when it's an appropriate time to start capturing value? All of these types of questions as well.
All right, so we still have a few minutes left in the session, so I wanted to open it up to the group. I mean, the research team is around all day today, all day tomorrow, and you have access to us beyond that as well, of course. But if you have a question you think you'd like to hear about now from the incentives part of the research group, now's the time to ask it. So,
yeah, I'd like to ask you, Scott, what do you think? It seems that with Faircaster, for example, the incentive is primarily targeting the creator, the content creator, and not so much the end user, which, I think their argument is that the end user doesn't really care. Maybe I'm misrepresenting what they think or said. You can correct me if I'm wrong, but, you can think that the user already has as an alternative Twitter and Instagram, which they get none of the value of the platform or ownership, right? But at the same time, it seems that if you're moving away from giving the end user ownership, it seems like that's moving a little bit away from the spirit of Web3, which is to share the ownership of the platform or the protocol with everyone. So I was just wondering, what do you think about that?
I haven't talked with the founders of Farcaster about how they conceptualize this, so I'm going to speak from my own sort of experience and analysis of the platform rather than from an understanding of how they think about these different components. But I actually think there are, so Farcaster does give users a very powerful form of ownership. And in fact, it's a form of ownership that we're actually seeing users with some willingness to pay for, which is that they own their social media platform identity, or social media protocol identity rather, and can use it interoperably across different platforms. And this is like, very absent from the Twitters of the world, right? Sort of a lot of people tried to leave Twitter to go and join Threads or Blue Sky or whatever, and they found they couldn't bring their social graph, they couldn't port over their content, they couldn't port over their reputation. This was very difficult. And so, Twitter maintains its gravity even in a world where at least many people think the sort of parts of the service have actually degraded. Whereas Farcaster, because people can switch clients freely, first of all, any value they build up on one client sort of is instantaneously viewable elsewhere, right? If you're spending a lot of time on far.quest, it also at the same time is like, growing your Warpcast, following and engagement along the way. But moreover, it actually places limits on how extractive any individual client can be, right? If Warpcast is, if the team that runs Warpcast is thinking about, sort of showing ads or charging fees or something, they have to be aware of the fact that people could just switch to Supercast or whatever else. Supercaster, I forget which one's the actual name. And so as a result, the user actually has much more power than they do in a typical social media ecosystem or in a Web 2 social media ecosystem. And so in that sense, I actually think they do have a critical core component of ownership that aligns very nicely with the user purpose of being on social media. The reason to do additional work to potentially in a context like that to incentivize creators is that creators often have to make a lot of investments before a social media platform is useful to them, right? You have to invest in building a following, sort of refactoring your content for this particular platform and so forth. And so they're the ones who actually face the higher activation energy at platform launch. Eventually, by the way, that starts to flip. So once you have a large enough user pool, now the user gravity often sucks in creators. This is why, like now, if you're starting off as a fashion, sort of like a bespoke fashion influencer or something, you just go to Instagram because there's a huge user base of people consuming that content. But early on, social media platforms often have to subsidize creators because of those initial investments that creators have to make before the platform is useful to them. And so I think of it more, it's not like both sides actually get ownership of their identity, ownership of their user graph, like of their follower graph, ownership of all their content and parts of their reputation. But when you're deciding how do you launch the platform, you start by subsidizing the side that's going to create value on the margin for the other side, so that like sucks in users of the other type and where the activation energy is higher, right? If you jumpstart a social media platform by saying to a bunch of users, hey, just come, there's nothing for them to do, there's nothing for them to see, so it's hard to get them to come. If you start off by sort of like seeding it with content by incentivizing some high quality content creators, then there's a reason for users to show up and that kicks off your flywheel. By the way, it's something I think Dan and the team at Farcaster did really well with the early scaling and like sort of like very curated early supply of creators, specifically geared towards making it a like really positive and high value environment to draw in users who are going to contribute to that.
All right, so I think we have time for one question if it's quick. So okay.
So this is just Pranav. I loved what you were saying about adversarial thinking, and I just wanted to kind of drill down on one thing you said, where you're exploring fee-based mechanisms in the more parallelized computation efforts, right? Where it's not just Ethereum one-dimensional thinking. I was just wondering if you could speak to just like some examples or like what you're actively researching on different fee mechanism strategies.
Yeah, so I think the one that's kind of most in production now is kind of what Solana is using. So I'll try to use in 30 seconds. Basically, Solana has this model where instead of making the block constraints just total gas limits, they have this account-based model. And they also have basically gas limits on the total number of transactions that can access one account, which is a much smaller fraction of the total block limit itself. And so this basically implies that kind of accounts that have kind of very high contention basically implicitly receive a higher price from the person who's building the block because they can't actually, they have a they're more supply constrained on how many transactions they can include that touch that one transaction, basically. And so I think this is basically like a V1 attempt at basically trying to incorporate kind of state-based pricing that gets to parallelism. Basically, you fill up a block with tons of transactions that are all touching different accounts, you can parallelize this thing way faster than if you can have these adversarial things. So if you pack a block full of transactions that have to be serially executed, then you've kind of lost the whole point of parallelization in the first place. And so yeah, I think this basically increasing the block constraints kind of like implicitly kind of affects the fees you need to access certain parts of state. And so I think that's basically like the first thing we've seen, but there's a lot of kind of ways to go in improving on that idea.